Hello, everybody, and welcome to week 11 office hours. Hopefully, you will be joining me soon. I am understanding that the SCU website has had a new transformation, and it's a new environment. I did have difficulties getting in yesterday, so it seems to have been repaired, so I was able to get in today. So I'm not sure if you are experiencing the same problems or not. However, this information will be there in a recording, so you could review it as a recording, as well as it will be posted on the discussion forum with the slides and the link for the recording, so that you can view this, though, when you do get into the school website. But just to let you know, we are just completed week 10. We are now moving into week 11. There are 3 more weeks. We have week 11, week 12, and week 13 for office hours and live lectures. Week 14, I will be posting information for you for the final exam with the study guide, all the exercises that we completed, answers to the exercises in the textbook, as well as the optional exercises that I'm offering during office hours. So you will have all of that then to use in your study for your final exam. I believe the final exam is the week of May 18th. So depending on your schedule and your studying, we will not be having any formal class sessions, but you can still, if you have any questions, post them in the discussion forum, so you and your classmates can collaborate on that, form study groups, and also review all the information and the materials throughout the week. There are midterm exam questions that may appear on the final exam. The final exam is comprehensive, so it will contain questions from all weeks of the course. So hopefully you got a good understanding of those chapters that were covered in the midterm exam, so you can review that material and then study well the material we covered after the midterm exam. This will prepare you very well then for the final exam. So again, we have our week 11, week 12, and week 13 of new material, where there will be office hours and virtual classes. After that, there will not be any live sessions. However, I will be posting information in the classroom, in the discussion forums for you to use. If you have any questions, please post them there. I and your classmates then will work on offering a good understanding of the material, offering answers and strategies to study for the final exam. Okay, onward now to as a review for week 10. Week 10, we covered input and output systems, so it was a manner of just looking at some of the input-output or I/O processes, and also how the operating system communicates with the hardware that is used for input and output. Some of this we've already looked at in the first couple of weeks of the course, especially week 3 for process scheduling, because we looked input-output requests are similar to any other process that requires some action from the operating system. So there is strategies for scheduling and strategies for algorithms on how to schedule, as well as how to access the input and output devices, and also how to coordinate these operations with the CPU, and additional perhaps memory strategies. So some of this would be familiar to you, and then some of it would be new and exploring specific input-output hardware and software, and how the hardware and software communicate together. So as a review, hopefully you got a good understanding. And as all the weeks, I offer you these topics. So these topics are a good way to get a brief outline, and also you can jot down brief summaries for these topics that'll give you a good head start for your own study guide then for when you approach the final exam. If you can understand these topics, have a good reference as to where additional detailed information is in the textbook, will then give you a good way and a strategy in studying for the final exam. And these are the assignments. Again, hopefully you had a chance to review all the resources. There was an article, and as I mentioned before, you have to learn how to reach out into the internet and networking with other professionals, so you can keep current with the latest and greatest technologies. They change very quickly. So you can't always go back and take a class to learn new technology or new material. So you have to reach out and Articles are a wonderful way to do this, and that's why some of the weeks we do have articles for you to read and discuss. Even though there is no any grade that's associated with any kind of article review, it still gives you good practice and good articles that you can use to get more information. Hello, glad you can join me. I know it's a new environment. Everybody's struggling to get into the new classroom environment, so I'm glad that you were able to get in and join me for these office hours. So I've just been reviewing a little bit about Chapter 10 and also mentioning how we have 3 more weeks of live office hours and virtual class lectures. And after that, you'll be preparing for the final exam. So we have week 11, week 12, and week 13. I am well, thank you. Hope you are well also. I will have a recording for this, so this way it'll be there so that you can get the first few minutes of this recording and you can review that, but I'm just reviewing Chapter 10. So hopefully you have no problems. I will be grading the assignments today and posting them. And we will now move on to week 11. And these were the assignments for week 10. We had a chance to review it and understand it. This is the answer to exercise 13.6. And it was reviewing how blocking material for input and output can be done. So it was a way to, again, just strategies. This is something we've already looked at in week 3, and then when we looked about memory management. Any kind of management takes a strategy because there's a lot of competing resources, processes competing for these resources, or just the action of the CPU. So these are strategies that are used because it's all a matter of performance and time. Typically, anything read out or read into or wrote to any external device, that's really where most of your time takes. The CPU is very fast, getting information into memory, and then from memory to the CPU is quick. But getting things from a hard disk or from a keyboard or from whatever input and device you have is what takes the longest time. So there are a lot of strategies that are used to optimize performance and speed. So these are some of the strategies, and your exercise 13.6 did address a common and more popular type of a strategy that is used. And again, we have various operating systems. Sometimes they'll use a variety of these strategies depending on what's being implemented and how the priorities are set up. Also, as I mentioned before, there's new devices coming out on the market, and a lot of these new devices now are the companies that are manufacturing software for these new devices are creating their own operating systems. So it's a good idea for you if you like systems programming and would like to be part of that new development and creating these new operating systems for specialized devices. Then understanding these strategies are very important, because it is something that you will then have to implement when you are then creating the operating system for a specific device. So the move is always to make something general purpose, so it can be an operating system that can run on a variety of devices and not just specific to one device. It just makes it better or a larger market for any company that creates an operating system. So right now, this is the transition that we're in, where specialized operating systems are coming out, but there is a move then to create some kind of a standard. So anybody who creates any kind of mobile device will have an operating system that will work on any of these mobile devices. Right now, it's kind of, we have the iPhone and your Apple technologies, or your iPads, and then you have the Android, which is for your other devices that are not working on iOS as any Apple products. And then now you have the Chrome coming out with their own devices with operating systems. You have Infinity coming out with their own operating systems. So we'll have to see where this takes us, but it's a great area right now for you then to continue and really use a lot of the information you use in this class to get on the cutting edge. Hello, glad you can join me. I'm glad everybody at least is getting in. I know there's a new school environment, so slowly you're coming into the classroom, but I do have this recorded, so you can then view the recording to get the first 10 minutes that I discussed. But it was pretty much, I'm still just reviewing week 10, chapter 13. Okay, these were the optional exercises. So I'm glad you're here, so maybe you know these answers or can suggest what answers you think there are. If you were able to review these optional exercises and look up the information to get the answer or not. But again, these are optional exercises you could use to study for your final exam. Hello, I'm glad everybody's slowly moving inward. Good to see you then in the classroom. Okay, so anybody have a guess at an answer? Hello. Glad to see you. Slowly but surely, you're all getting in. Again, as I mentioned, there's a new environment for the classroom now, and there were some glitches yesterday. I could not get in. So I'm glad that you're all being able to get in now. A little tricky. The sign-in is in a different location now, so you have to sign in before you can click on anything. Before you could click on it, it'll automatically bring you to the sign-in screen, but now you have to sign in first. So that's what I experienced. And the links didn't work, but they are working now. So I'm glad you're all able to join me. Okay, so does anybody have an answer for this question here? An interrupt priority scheme. Now, we did look in week 10 or chapter 13. We looked at interrupt and polling, some two popular strategies that are used for input and output devices. Interrupt is a strategy that is used in a lot of operating systems, and that is when the operating system is functioning or working or just waiting. An interrupt is sent in then to say, hey, I need some action or some work. Okay, we got a possible answer here for C and a D. We have a variety of answers here, and the answer is D, all of the above. So when you have a interrupt and priority are the two keywords here. Priority means there is a different level. Some things need more urgent attention, and if they do need more urgent attention, then they are let through. So allow the most urgent work to be finished first. Make it possible for high priority interrupts to preempt the execution of a low priority interrupt. Again, we looked at this when we talked about processes and scheduling processes. Remember, input and output request is just a process. Very similar, but it's just specialized kind of process because it deals with input and output devices. So they kind of are lumped together and categorized together. And then defer the handling of low priority interrupts without masking off all interrupts. Now how it's handled, yes, if something is running and something with higher priority comes in, what do you do with what was already running? So there's different strategies there. You can't just stop it and never complete it. So there has to be a way to know how to resume later after the high priority interrupt is taken care of, and then you can go back to the low priority interrupt and continue where you left off. So it's very important to keep track of that. You can't just leave it hanging or stop it altogether and then it never gets completed. So hopefully all interrupts will get completed, but depending on their priority will determine when and who goes first. Very good. Okay, a character stream device. We looked at character streams, we looked at blocks. These are different strategies, and this kind of also carries over into the programming world, not just for operating systems, but the programming world, because when you are creating a program, you're also working with data. So you have to determine, every programming language will have a variety of functions or procedures or objects in order to handle the data that's flowing out of a program to the operating system, and then from the operating system to the device, or vice versa. So what are your answers here? What do you think? Character stream device. Transfers data in blocks, transfers data a byte at a time, is a device such as a disk drive or is similar to a random access device. Okay, we have some possibles here. It's B, transfers data a byte at a time. How you know this is because a character is our way of Every character is 1 byte in size. So when you hear character, you got to think of bytes. That's how we have ASCII code. That's how we translate our world into the computer world. Remember, the computer understands zeros and ones. It doesn't understand A, B, or C. So you have to, there's a pattern for every letter or character or symbol. And they are put in 8 bits, a pattern of 8 zeros and ones, and that's known as a byte. 8 bits is a byte. So when you see character right away, you should see byte. Explain the concept of polling between a host and a controller. Again, this is the other strategy. You can either poll or you can interrupt. So, being that this is an essay question, here you go. When a host tries to access the controller, it constantly reads the status of a busy register and waits for the register to clear. This repetitive checking is termed as polling. So that's what polling means in this strategy when you're working with input and output. And it really, when you're talking about a controller, you could be talking about the DMA controller. That was that strategy to bypass the CPU and let the DMA then take control and do some of the processing so that the CPU is not bothered. So it's another strategy. Again, it's just a matter of speeding up the process because reading and writing is the most takes the most time in any kind of data transfer. What are the 3 reasons that buffering is performed? So a buffer is another technology. Typically all your devices, your input and output devices will have some form of a buffer. And again, that's because of the speed. You know, it's faster for the CPU to process than it is for the device to get the information to the CPU. So you can, this allows you then to continue, and then it puts the information in a buffer, and then when the CPU is ready, it then sends it to the CPU. So it's a way of just speeding up the process. But a buffer is a memory area that stores data while they are transferred between 2 devices or between a device and an application. So buffers are used in a lot. I mean, they're used here. Cache is a specialized kind of buffer, but it's in the category the same as a buffer. So when we look at cache memory, or using even part of the hard disk as cache memory. Same thing with the buffer. It's just to store information coming from a device and transferring it then to an application to be processed. But one reason for buffering is to handle data when speed mismatches between the producer and the consumer of a data stream. The second reason is to adapt between devices that have different data transfer sizes. That's probably the most popular reason. And the third reason is to support copy semantics for application input-output. If you have it in a buffer, it allows you then to check it first before it goes to its final destination. And sometimes in error checking, we use the buffer version because instead of sending it, then seeing it's wrong and have to send it again, at least we're just using the buffer rather than the final destination, which then can, you know, cause just longer time. Okay, what are the various kinds of performance overheads associated with servicing an interrupt? Remember, we have 2 strategies, interrupt or polling. And when an interrupt occurs, the currently executing process is interrupted. And again, we looked at this already when we looked at process scheduling, and we looked at how priority scheduling, if it was preemptive or non-preemptive. So these are the same strategies that are used for input and output requests because it's the same thing as a process. So when an interrupt occurs, the currently executing process is interrupted and its state is stored in the appropriate process control block. The interrupt service routine is then dispatched in order to deal with the interrupt. It has to determine what kind of interrupt it is and what needs to be done. And when it's completed, the state of the process is restored and the process is resumed. Therefore, the performance overheads include the cost of saving and restoring process state and the cost of flushing the instruction pipeline and restoring the instructions into the pipeline when the process is restarted. So again, you have to keep track. If you're interrupting, you have to keep track of what was running. You have to keep track of what it is you want to run, and then you have to be able to transfer or when one is done, be able then to restart the other one or resume with the other one. So it's just strategies, again, when everybody's competing for the same resources and what's to do so that you can satisfy all the requests. Okay, which of the following is true of a blocking system call? Any possibilities here? Any answers? A, B, C, or D? What do you think? Application continues to execute its code when the call is issued. The call returns immediately without waiting for the input-output to complete. The execution of the application is suspended when the call is issued. Or blocking application code is harder to understand than non-blocking application code. Answer is C. The execution of the application is suspended when the call is issued. That's, I guess, when you think of blocking. Blocking means it stops something. Okay. A blank is a buffer that holds output for a device that cannot accept interleaved data streams. We have escape, block device, cache, or spool. We have a spool. This is very similar and used for printing. When you're printing, you typically will have a spool, queue for the queues. So it'll hold the information. Because you know yourself, when you maybe submit several documents to be printed, they all are the request is issued, and then it's just this buffer or the spool that holds the data so that when one document is completed and printed, then it will then go to the next data that needs to be printed. So depending again on your printer, your output device, will determine how large this buffer is and how it interacts. It's the device driver that manages all this information, and the device driver will then determine, is there a buffer? How large is the buffer? Where is the buffer? The device itself can have some form of a buffer, and then it needs to interact with the operating system, where the device driver may set up some internal type of a buffering. So spooling, when you hear spooling, is right away associated with printers. Which of the following is a principle that can improve the efficiency of input-output? Increase the number of context switches, use small data transfers, move processing primitives into hardware, or decrease concurrency using DMA controllers. So what are your thoughts here? Anybody? C, move processing primitives into hardware. Again, you want to decrease concurrency using DMA controllers because DMA controllers can help. Remember, it does some processing, so it can execute at the same time as a CPU. Maybe CPU will handle some of that, and the DMA will handle some of that. So that will actually be concurrency that is increased. Using smaller data transfers, that won't help in efficiency because our goal is to get all of it transferred faster. And increase the number of switches. Well, anything switched takes longer time because you need to process the switch. So it's moving processing primitives into hardware. So if you can have your hardware do some, again, it's just a goal of leaving less for the operating system and CPU to have to handle. If you can handle some of this without using those resources, then it's going to get done faster. Okay, this one, I guess, I apologize. This is the same question as we had before. So we did look at this question already. I have a duplicate here. Do we have any questions? Where do we have questions? I see some question faces. Are those questions? I see smiley faces. I don't know. Are they smiling or no? Or not? Okay. It's a good smile. A good smiley face. Good. Okay. Okay, the blank register of an input-output port can be written by the host to start a command or to change the mode of a device. Again, we had different registers, and they were there for different purposes. Again, it's all to help the efficiency of the processing and the requests for the devices or the resources. It's always a goal of how can we make it faster? What can we use to help out the CPU? What can we use to help out the data transfer? So registers are one that are used because registers are just memory locations that are closer to the CPU or maybe on the microprocessor chip itself. So if it's closer, then it's less time that it has to travel, so it's faster. So the answer here is B, a control register. Good, yeah, B or D, transfer register. A transfer would be in the midst of transferring, so it would contain more data than it would contain more control. It probably would take over after the control register, but again, it all depends on how it is written. This is just the most common strategy that's used. And again, as we know, operating systems vary as to how they write this. Device drivers vary, and our hardware devices vary. So depending on what you're working on will determine who's doing what kind of helping and how it's all configured. Okay, so Chapter 14, we are now moving to system protection. Again, we have week 11, week 12, and week 13. These are the weeks left for new material. We are approaching the end. After week 13, there will be no more live office hours or virtual class sessions, but there will be information posted in the discussion forum for you to use to study for your final exam. My understanding is that your final exam is going to be the week of May 18th. So while we won't have any live interaction, you will have a wealth of information and resources to use to study for your final exam. Okay, Chapter 14 is system protection. This is very important and actually has increased in importance because of all the remote access we are using now to systems and also the multi-user aspect of systems. So we need to determine we have a lot of data, we have a lot of information on our systems today. So we have to make sure we will determine who can do what. Typically, you will have administrators that are allowed some tasks that they can do, but regular end users cannot do those same tasks. And that is for the sake of protecting the system. You can't just allow anybody into the system. They may be deleting files and wreaking all kinds of havoc for the system. So we have to now have some level of access control to determine who can do what, so that we cannot then have to protect the settings and the files on our systems. So it's just the protection refers to a mechanism for controlling the access of programs, processes, or users to the resources defined by a computer system. And this is a very crucial, important area that it's done correctly, and all operating systems will have a manner to allow you to make these settings. Sometimes you will have network administrators. No, we still have two more to go, 2 more chapters to go. I believe it's going to be Chapter 15 and Chapter 17. Those are the next 2 chapters we'll be reviewing. Chapter 17 is just a look into Windows, a little more in-depth look into the Windows operating system. So it's Chapter 14, 15, and then 17. And from there, the final exam will contain questions from all the chapters, but use your resources and references that you use for your midterm exam to study for the final exam, for those portions of the questions on the final exam, and then a new material. Again, you have the list of topics. I will be giving you a study guide for the final exam. You will have the optional exercises and their answers. You will have all the end of the chapter exercises and answers, including your homework assignments. And additional information, just targeting some of the areas that you need to concentrate on. Very similar to what you received for the midterm exam study guide, you will get one also for the final exam study guide. So with all those resources, hopefully that will help. Again, a lot of those optional exercises I'm giving to you are questions that may appear on the final exam. So make sure for at least know those, and then the answers to all the exercises at the end of the chapter. So that is definitely something to review. And again, you're not learning this material just to pass the exam. You know you have to understand this, because in the workplace, you can't really fool anybody. So you really have to understand the material. And as I mentioned before, if systems programming is something that appeals to you, something that you find you have a natural gift for, then this is a very good time to enter the field, because as I mentioned before, all the mobile devices are now spurring new technologies and new creation of operating systems. It's not the standard anymore. There's not those general purpose standard ones either for a Windows PC or for Apple products. There are now for specific mobile devices, and a lot of different companies and manufacturers are jumping on the bandwagon to make their own specialized operating system. So understanding this then can get you on that bandwagon, and it'll be very revolutionary and lucrative. So something that you may want to look at. Okay, so anyway, back to system protection. Again, this is something operating systems need to offer you when you become proficient in an operating system. You will learn how to set these up. There are going to be GUIs or graphical user interfaces that come up on the screen that are created by your operating system to help make all these settings for you. You know, where you identify someone as an administrator, or you identify someone as an end user that does not have administrative type of powers. So the access matrix is what you use then to keep track of who has what level of control. It's very important to create this. You will have, when systems are set up, there will be someone in a company that is in charge of this. And also user IDs and passwords have to be kept safe, so that nobody else can get into someone else's user ID and password configuration, because then they can log in with perhaps access level rights that they should not have. It is a prime target for hackers and those who are trying to break security. So there has to be a lot of careful planning, designing, and protection of this information. So the access matrix is a general model of protection that provides a mechanism for protection without imposing a particular protection policy on the systems or users. In other words, there are settings that you can do. Every company has their own policies and procedures and need to be allowed to then customize the settings to fit their purposes. And that's just a matter of specifying access rights. In other words, who are administrators, who are just end users, and depending on what department will allow them into different areas of information. And this is very important for network administrators, because not only do you have, one computer, you're going to have a network of files, directories, software, all sorts of information. So these are the topics for this chapter. Again, write down brief descriptions for yourself. If you have any questions on anything, please bring it into the discussion forum so we all can work together on helping you understand it. Also, if you find additional resources or links or videos that you say help explain some of these topics, and it is understandable for you, more than likely it'll be understandable for your classmates as well. Again, don't rely just on one area to try to understand material. Perhaps the way it is written is not clear to you, but that doesn't mean you're not going to be able to understand the material. All that means is that the author wrote it in a way that doesn't make sense to you. So sometimes it's helpful for your classmate to explain it to you, because you understand your classmate better. or you find another resource or a textbook that explains it better for you. So make sure you understand it, but don't think you're tied to just the resources in this class. Go ahead and research on the internet. That's how you're going to get, different versions of the same information, but versions that maybe make more sense to you, and bring it into the discussion forum, because then you can help your classmates out. It may make better sense for them as well. So please do that. There is a video that I did post that maybe gives you an overall general introduction to this information, so that may help you before you get into the detail that's explained in the textbook. So hopefully you'll have all these resources to help you. There's the PowerPoint presentations, there's the video, there's no article. I do apologize, that's last week's article, but if you didn't get a chance to read it last week, then you can read it now. So, and also there's in the classroom another video. So please make sure to review these. And here are your exercises for this week. So again, if you have questions on it, post it in the discussion forum. That's what we're all here for. That's how you can access everybody, because they all will look there, and that's how they'll know that you have a question or you want some more assistance. And that's how I will know you need more assistance. So then I will give you, help answer the question or help strengthen your understanding of the information. Okay, so this is the 1411 and then 1414. This is your questions for today. Oh, you're quite welcome. That's what I'm here for. So hopefully I'm helping you out. You're not alone in a vacuum. That's what we're all here for, to work together to help understand this material. And here's your additional optional exercises. Again, some of these questions may appear on the final exam, so it would be worth your while to go through them and try to answer it. I also have the section numbers here, so do make sure to look through the section to find the answer and understand the other, items that are mentioned in that section. So we have, again, 10 optional exercises here. Some are multiple choice, some are essays, but that's similar to the final exam. You will have multiple choice. You will also have some short answer essays. It's very similar to the midterm exam. Once you took the midterm exam, you know now how the exam will be presented and how you have to study for the exam based on the type of questions that will be given. So we have a variety here for you to then go through as you read those sections. Looks like I have an answer there. I snuck in an answer here for this one. There you go. By accident, I forgot to delete it. So you have one answer here. And then here's the other one. Okay, so any questions so far on either Chapter 13 or the new one coming up, Chapter 14? Good. Okay, so I'll leave you then today and let you use this extra time to start reviewing the resources if you haven't already, or work together and collaborate on the answers to these exercises, or even working on the homework assignment, the exercises 1411 and 1414. So have a wonderful evening, and I will then see you on Wednesday, same time, same place, for our virtual class. And if you have any questions, don't hesitate to bring them up during the virtual class session, or post them in the discussion forum for everybody to see your question, because they may have the same question, and this way we can all see the answer. Okay, have a wonderful evening, and again, we will see you on Wednesday. And hopefully you're getting into the classroom okay. Again, there's a new setup for the environment for the online classroom, and at least you made it here. Do help your classmates out in case they have trouble finding it or getting into the system. So, but you will be required to be here for the virtual class session. As always, attendance will be taken and it will be monitored to make sure you're here. So have fun learning the new material. Make sure you review the old material. It helps you better when you study for the final exam. And then we will see you on Wednesday. Have a wonderful evening and goodbye.